You've probably heard these terms before.
It's declarative.
Declarative.
One's imperative, one's declarative. Super declarative. It's declarative.
Declarative transitions.
Declarative way, imperative way, declarative way, imperative way. Declarative way to imperative way. Yeah, whenever we have a declarative API, we've got an imperative one.
What exactly do these terms mean? The problem is if you look them up, you usually get something like this, where imperative programming is how you do something, and declarative programming is what you do. The problem is that makes perfect sense after you've learned about the difference between imperative and declarative programming. Combine that with the fact that people use the word declarative to mean something is good nowadays, and the topic is fairly confusing. But let's back up, because there is something in these definitions. To better make sense of them, let's look at a real-life example. Say we've been listening to a lot of Beyonce lately and had a craving for a certain American casual dining restaurant chain.
Come on into Red Lobster.
One approach for getting a table may look like this, where we walk up to the waiter and say, I see that table over there by the Gone Fishing sign is empty. My husband and I are going to walk over to the bar, take a ride to the bathroom, walk past the two tables, and then sit down. Another may simply look like this. You walk up to the waiter and say, table for two, please. One of these approaches, the imperative approach, is focused on how you're going to get a table. The other, the declarative approach, is focused on what you want, a table for two. Let's look at some code. Say we wanted to write a function called double, which takes in an array of numbers and returns a new array after doubling every item in the original array. One approach may look like this, where we times each number in the original array being passed in by 2, push that into the new array, and then return the results. Next, what if we wanted to write a function called add, which takes in an array and returns the results of adding up every item in that array? Again, a similar approach may look like this, where we create a variable and set it equal to 0, then we add the value of each item in that original array that's being passed in to this variable and return it. Last, let's say we wanted to add a click handler to the element which has an ID of button. When clicked, toggle the highlight class as well as change the text to add highlight or remove highlight. One approach may look like this, where first we'd get the element that has an ID of button. From there, whenever the user clicked the element, we toggle the class and, based on its current state, update its text. Now, is this code bad? Well, of course not. But in each of these examples, we're conforming to the operational model of the machine by describing how we want to accomplish a certain task rather than what we want. Another way to think about the difference between imperative and declarative code is if you can trace the execution of the program as it runs. In each of these examples, we can very clearly trace how the program is going to run. This forces us to, again, think like a computer in a very operational way rather than as a human. So now the question is, how can we update this code to be more declarative? Let's take a look. For double, we can leverage JavaScript's map method to return a new array after multiplying every item in the original array by 2. For add, we can leverage JavaScript's reduce method to return a new number after adding each item in the original array to that number. And for our button logic, we can encapsulate that behind a button component. The library we use for this is just an implementation detail. The bigger takeaway is that writing reliable software is all about properly managing complexity. What we've done is we've taken our imperative operational-like code and abstracted it behind a declarative API. In fact, many, if not all declarative APIs, have some sort of underlying imperative implementation. This makes sense. If our argument is that declarative code conforms to the mental model of the developer rather than the operational model of the machine, then ideally we'd want to abstract away most imperative code behind a declarative API. Now, if it still hasn't clicked, let's look at some purely declarative code. Here's some SQL which is selecting all of our Mexican users. It's the perfect representation of declarative code. We're describing exactly what we want, Mexican users, without having to instruct the computer how to do it. Another example of declarative code is HTML. We're not concerned with how the web browser is parsing our article element and displaying it to the screen. Instead, we describe what we want, a new header and a paragraph, rather than how we want it. Another example, CSS. Again, what, not how. Now, another less spoken of benefit to declarative code is that your program can be context independent. This means that because your code is concerned with what the ultimate goal is, rather than the steps it takes to accomplish that goal, the same code can be used in different programs and work just fine. This is hard to do with imperative code because often, by definition, imperative code relies on the context and current state of the program it's running in. Table for two, please, is universal, where I see that table over there by the Gone Fishing sign is empty, works only at the highest quality establishments.